Hello and welcome to everyone. Today in the topic leveling, we are going to see some of the solved problems based on collimation error, based on error due to curvature of the earth and refraction. Then at the end we are going to see a problem based on distance to visible horizon. Now, without wasting much of a time, let us continue with the next. Then problem based on collimation error. Let us see a problem which is based on collimation error. A level was set up on extended line BA in a position 70 meters from A and 100 meters from B, reads 1.684 on the staff held at A and 2.122 on staff held at B. The bubble having carefully brought to the center of its run before its reading. Now here a level was set up which is on the line BA. BA has to be produced extended line. Then the level is set up 70 meters away from A and 100 meters away from B. The staff reading at A is 1.684 and the staff reading at B is 2.122. Now it is known that the reduced level of the pegs at A and B are 89.620 and 89.222 respectively. Now here the reduced level of A and B is already known. Now find the collimation error and the readings that would have been obtained had there been no collimation error. Now what we can expect here is there is going to be some collimation error and we have to find out the error for collimation. Then in the next part we are going to find out if there was no collimation error, then what will be our true staff reading or the correct staff reading. Now let us see how we can represent the particular problem in a pictorial way. Now here is the surface of the earth on which we have stations A and B. So now A and B are the two stations where we are going to hold a staff at A and again we are going to hold the staff at B. Now the instrument is placed in such a way that the BA extended, we have to place the instrument in such a way that the instrument is 70 meters. The distance between two A and B is 30 meters. So how it comes up? The distance between the instrument and the station A is 70 meters and the distance between station B and the instrument is 100 meters. So it comes up to be like this only. So what is the distance between A and B is 30 meters. This is our line of sight. Now due to some collimation error we will be having something like false line of sight should be something like this. So now yet we haven't known whether it is inclined upward or downward. However, let us assume that the false line of sight is inclined upward and it is making an angle alpha. So now the staff reading at A is 1.684, then the staff reading at B is 2.122. So now we are going to find the reduced level at A is also given as 89.222 and the reduced level at A is 89.620. Then we are going to find this portion of error in collimation. So how much the error is coming up at staff B, and again later on we are going to also find out how much of error is coming at staff B. So for this moment we will try to find out how much error of collimation is coming up with respect to station B and for a distance of 30 meters. Now this is the particular figure that we have just seen. Now let us see true difference or the exact difference in elevation of B and A. So what will be the exact difference between B and A? Let us see. Now here The two difference or the exact difference in elevation of B and A is given by the difference in their reduced levels, the value of the reduced level, that is the reduced level of A minus the reduced level of B. So it comes up to be 0.398 and B is the lower station. Now as per observation, difference in the staff readings or the readings of the staff is equals to, which is given in the question as per the values given in the question. If the difference in the readings of the staff reading is 2.122 minus 1.684, you just take a difference between the staff reading at B and staff reading at A. Here again the station B is lower, so the value comes up to be 0.438 meters and B is the lower station. Now what can we see from here is, since the difference in staff reading is greater than the difference in the RLs, the collimation line is said to be inclined upwards. Now the difference in the staff reading and the difference in the true difference, if we compare both of them, the difference in the staff reading is slightly greater than the difference in the true difference. So now we have an idea that our actual line of sight or the line of collimation is inclined upwards. So this shows that the staff reading at B is also, again with this we can see that since B is actually a station which is at the lower level than as compared to A, however this also shows that the staff reading at B is greater than that what it should be. So the actual should be something else, but here it is showing something at a greater value, the value of the staff reading at B. Now hence the line of sight is inclined upward by an amount of, you just subtract the value of the staff reading difference with the difference in the reduced levels. So 0.438 minus 0.398, you get a value of 0.040. So you get a value of 0.040, which is the amount of error which is occurring for a distance of 30 meters. So now let's see and move on to the next step, where we will find out the angular collimation error. So now this is the amount of error that we have found out, that is shown in the figure again as 0.040, that small portion of inclination which is again given there. Now therefore the collimation error comes up to be around 0.040 meter. Now also the angular error of collimation is given by tan alpha equals to 0.040 divided by 30. Now how does it comes up? Let us see. This is a portion of that particular figure in which we will try to concentrate on this small triangle which is formed by the base as 30 meter and the perpendicular as 0.040. If we take a tan alpha of that, then we will get a value of 0.040 divided by 30. This will give us, with this particular equation we can find out what is the value of alpha, that is the angular error of collimation. So this particular portion that we are talking about, now the value of alpha is equals to tan inverse of 0.040 divided by 30, which gives us to a value of 4 minutes and 35 seconds. Now again let us see and try to find out the actual readings of the staff with if there was no error in the collimation. Exact staff readings if there was no collimation error. Now for at station A, we are considering station A, then we are going to see for a distance of 70 meters, which is the distance between the station A and station A and our instrument. Then, and the actual value for staff reading which was given in the question was is 1.684. However, this reading is more than what it should be because there is some kind of error. So we are going to subtract that particular amount of error. So how does this value for 0.040 divided by 30 into 170 comes up? Let us see here. Now for a distance of 30 meter, it was 0.040 amount of inclination. That is, the error amount was around 0.040. However, for a distance for 70 meters, it will be 0.040 divided by 30 into 7. This is very simple. If you keep a good watch over the particular figure, you can find out easily how does it comes up. Now just solve it and we will get a value of 1.591 as our actual or the true reading on the staff, which should be if there were no collimation error. Now at station B, the value for the staff was around 2.122 and the distance where we are measuring was around 100 meters. Now for a distance of 100 meters, how much should be the amount of error it should have occurred when we are actually sighting from the instrument to the staff which is held at B. So 2.122 minus 0.040 divided by 30, and again it is for a distance for 100 meters, that is in between the station and the instrument. Now you just solve it, you will get a value of 1.989. So now let us check whether this particular value that we have found out with our with the correction, and this should be our true staff readings when there were no error. Now let us check whether this is correct or not. How to check? Hence the true difference in the elevation, just subtract the value of the elevations of the station A and station B, that is 1.989 minus 1.591, we will get a value which is equal to 0.398, which was the true difference or the exact difference in elevation of B and A. This value was equal to the difference in the reduced levels of B and A. So now we can say that there is no error here. We have already subtracted the value of the error, or we have already corrected the error in both the station where the staff reading was taken. So this should be our true staff reading, and the true difference in elevation is also correct, and it is equal to our true difference or the exact difference in elevation, which was found out by subtracting both the reduced levels of A and B. Now let us see a next problem in which we will try to correct the error due to curvature of the earth and refraction. This is a particular problem. Let us see how to solve it. In order to find the true difference in elevation between 2 points P and Q, a level was set up on the line PQ 60 meters from P and 1280 meters from Q. So now we have to find a true difference in elevation between 2 points, which is P and Q, and a level was set up which is on the line PQ, where the level was set up at a distance 60 meters from P and the distance of the level from Q is 1280. Now let us see the reading obtained on staff held at P and Q respectively is 0.545 and 3.920. So the respective readings were also given. Now we have to find out the true difference in elevation between P and Q. So now Let us see, this is the surface of the earth on which the particular readings were taken. Here is the point P and Q. Now our instrument is to be set up in such a way that it is set up on the line PQ, and our instrument is 60 meters away from P, and it is 1280 meters away from Q. So as both staff were held at P and Q, and the corresponding readings were taken at P, which was equals to 0.545, and at Q it was 3.920. So this is the setup that we are going to do in the particular field. Now for this particular setup, we are going to find out true difference in elevation between P and Q. So we are going to find out the true difference of elevation between P and Q. However, we are going to be facing some error due to curvature of the earth and refraction. Now we have combined correction. Now we have combined correction for curvature and refraction is given as by C equals to 6 by 7 times of d square by twice r, which I have already covered in previous lecture also. Now correction for the staff reading at P is given by, now we will try to find out the correction for both the stations, for station P and station Q, and let's see how much error is coming up due to combined correction for curvature and refraction. Now for station P, let us just put it as Cp equals to 6 by 7 times of d square by twice r, where the value of d is 60. That is nothing but the difference, the distance between the instrument and the station. Divided by 2 into 6370 into 10 to the power 3. Now why I multiplied this value by 10 to the power 3 is in order to convert it in terms of meter. Now the radius of the earth is 6370 kilometers approximately, so we just convert it into meters by multiplying it with 10 to the power 3. Now here we got a value of 0.0024 meters, which is quite small and which is negligible. If you want to correct it, you can correct it, no problem, but in this particular problem the value is very small, so it is quite negligible. Now let us see for the correction of staff reading at Q. It is given by CQ equals to 6 by 7 d square by twice r. Substitute a value of d and r here. Now d value is 1280, that is the distance between the instrument and your station Q. R is the radius of the earth. We get a value of 0.110 meters, which is the correction. Now correct staff reading at Q is given by, the staff reading which was given in the question was 3.920 minus the correction, that is 0.110, which we have just calculated. It will give us the correct staff reading at Q equals to 3.810 meters. Now the true difference in elevation between P and Q, we have the staff reading at P and Q. Q just we have found out just now, and P, for P the correction was very small and it was negligible, so we are taking the value for the staff reading which was given in question for P is correct, and the corrected value of Q we have already calculated just now. So the true difference in elevation between P and Q is given by 3.810 minus 0.545, which will give us to a value of 3.265 meters. This is the value of our true difference in elevation. This is the end of the particular problem for finding out the true difference in elevation due to curvature of the earth and refraction. Now let us move on to another topic in which we will try. Now let us see a problem which is based on distance to visible horizon. An observer standing on the deck of a ship just sees a lighthouse. The top of the lighthouse is 42 meters above the sea level and height of the observer eye is 6 meters above the sea level. Find the distance of the observer from the lighthouse. Now here in the sea there is a ship and on the deck of the particular ship an observer is standing and it is looking through the horizon of his eye level, where he just sees a lighthouse. Now here in this particular question, the height of the lighthouse is given and also the height of the eye of the observer is also given. Now we have to find out the distance between the observer and the lighthouse. Now how do we calculate it? Let us see. How do we apply the basic of distance to visible horizon? Now let us see, this is a lighthouse, then here is the ship, and on the deck of this particular ship an observer is standing and seeing towards the horizon where he just sees a lighthouse. Here is the line of sight. Now the height of the lighthouse is given as 42 meter, let us say h1, and also the height of the ship is given, or the height of the observer is given, where it is equal to 6 meter, let us say h2. Now the distance d1 is the lighthouse, distance of the lighthouse to the visible horizon, and this is the d2 is the distance of the observer, for it is the distance to visible horizon from the deck of the ship. Now let us see how to solve this problem. Here let us again see in this picture and find out. Let h1 is the height of the lighthouse, 42 meter given in the question. h2 is the height of the observer, that is 6 meter given in the question. d1 is the distance of the visible horizon from the lighthouse. d2 is the distance of the visible horizon from the this should be from the deck of the ship. I have wrongly mentioned as lighthouse here. Now therefore the distance of the lighthouse from the observer should be sum of the both the distance d1 and d2. Now how do we calculate the value of d1 and d2? We have already discussed earlier in our particular video lecture for distance to visible horizon. Here d is equals to d1 plus d2. Now the formula for d is given by root over 14 times of r into h by 6. Here just substitute the value of r and h1 and r and h2 in this both the equations, then you just found it, you just get a value like this, which is 6370 is your value of the radius of the earth, and h1 value is 42, then h2 value is 6 meters. So if you solve it, we get a value of 34.42 kilometers.